Sí. Now we start the last module of this event, quality assurance. It's essential or critical so that the whole work that the labs and analysts are doing, they are having the trust that the farmer needs. So we present Jessica Matilda. She studied at the University of the Republic, and she is working at INASE's lab as a quality assistant. So good afternoon to everybody. Before starting this module, I would like to add that it is important to have added this part of to this workshop or meeting, because we believe that all the quality controls, they go hand in hand with all the processes we have seen today. So I will talk about assurance of validity of the results of the tests, highlighting that all activities have to be controlled. What does it mean to assure the validity of results? We have to permanently evaluate, and it has to be a critical evaluation on the analytic methods and the performance of the lab. Why? To assure that the whole process is under control. What does it cover? It's that all activities that are part of the process, they are controlled. And the analytical process, it comes from the request, certificate, analysis certificate request or test certificate request, and all steps in the middle, the sampling, the analytical process, the results, and until we get the final product of the lab, which is a test certificate. So we can ask ourselves, how do we do all these controls along this process? We can start with a review, to review the certificates requests. And that's what we do is to evaluate that the species that is requested to be analyzed is under the scope of the accreditation. Why? Because sometimes there is an organization that is, when they give us the accreditation, they are accrediting for the evaluation of some species. So to assure the quality of the results provided by the lab, it is important that it happens, or it should be a communication with the customers if this is not under the scope of the lab. The analysis should be proper to the request of the customer. As this is a seed test analysis, we are ruled by the ISTA rules. We are governed by the ISTA rules, and they should be adjusted for a seed test lab. But they might ask for a test that is not under the ISTA rules. We can do it, but the lab must be sure that this test is appropriate and that it's good to assure quality. And third, that the lab is able to adjust to the workflow. Sometimes the workflow increases in some times of the year, so the lab has to be capable to plan this kind of situations, for instance, by hiring some people for some special periods of time or some extra help. Another important or critical issue is to review the documents and registers. The lab must be sure that the documents, the reference documents are in force and they are updated. And then the lab has to have a documentary system under control that is reviewed regularly, or some revisions that are programmed or extraordinary reviews. We will see how it is important to plan everything in the labs, and everything has to be planned. All documents have to be up to date, so that we are sure that the lab, the procedures the lab is using are exactly how they should be for the lab. The ISTA rules, they tell us about the procedures, but it is important that the lab tells us in the procedures or establishes exactly which are the activities they do and how they change them, and they keep us updated. It is also important to keep documents and records, to keep an eye on the integrity of documents and registers, so avoid losing information, and to assure the traceability. So there must be a proper backup. The lab has to have strategies for e-documents, for instance, that there are tools, for instance, excuse me, that protected by passwords, that the documents are only for reading only, and the access is protected, and that the storage is a proper storage in case there are some documents that are printed, so that the lab is not losing or dumping documents that are important. Regarding traceability, it's important to keep traceability, because when there are some special situations, we need to go back and look for former documents. So it is highly important that the laboratory has a record of all the activities, as well as the records of tests when information is transferred to electronic records. We also have the revision of analytical results. One good practice before issuing the report is to detect analytical errors or mistakes, to monitor the stuff. So these mistakes, they can come from, let's say, some species is wrongly identified, or it can happen that some figures are not right. And it's also important, another step, to make a revision of the certificates. It is critical to assure the quality of the final product of the laboratory, that is the analysis or test certificate. We avoid to get complaints because of wrong results that we issued. So this is very important, and it is important that it's not always the same person that is doing it, in order to minimize the risk of issuing certificates with mistakes. If we get any complaint, it is very important that the lab is taking care of them. We should analyze what has been going on, to take measures and then inform the customer. To control the equipments and facilities. Equipments are critical too, to assure the validity of the results of the test. So before starting to use an equipment, we have to check that it is proper for the use we want to make of it. So we have to calibrate it. For instance, if we have a germinator, and we want to work at 20 centigrade degrees, we have to see that the chamber is homogeneous, that the variety is plus minus 2 centigrade degrees. And what's the use that how it can happen. If the equipment is, it doesn't mean that the equipment is no good, but you have to be sure that everything is set in the right way. Then when we verify that it's proper for the use, we have to have a program to verify, calibrate, and to do maintenance to be sure that the equipment is going to work in a proper way. To use calibrated samples and also reference patterns. That's very important. We have to use them for every cases to check scales. We have to use calibrated weights, for instance. For thermometers, we have to have some reference thermometers. And something very important, we don't have to forget the facilities and the environmental conditions. It is critical to have a control on that, and it's very important the place where we store the samples to keep certain conditions, so that if I have to repeat a test, it's possible to reproduce it. Quality control of substrates and reactives. It is important what we use to control the substrate, paper or sand. How is the pH, the conductivity, phytotoxicity, and so the pH has to be controlled. And before we can send a batch, we have to take care of that and see if we want to. We can compare a former batch with the one we are analyzing and see if they are having the same results. Another important thing is to determine the water retention in these substrates that are used for germination, because the amount of water would affect the growth of some species. So that retention is important, and then we adjust it for the different species that we are analyzing or testing in the lab. Control of solutions that are prepared in new batches with tetrazolium salt. Tetrazolium is used, and when we prepare a tetrazolium solution, ISTA establishes that what the pH is the right, what is the right pH. So we have to check it and use these strips to check that. And at the same time, when we get new tetrazolium batches, we have to compare with the former one we got that we already know and it worked properly, and compare them with the tolerance charts. So we run 400 seeds with the old one and 400 with the new one, and we compare the results. Yes, this comparisons is under the tolerances of the charts. If it's according to the chart, the ISTA chart, then we accept it or not. An important thing to assure that the tetrazolium is adequate, the pH, we can use a phosphate buffer to assure this pH. In many labs, they use water from the tap, but this sometimes the pH is wrong and you end dumping the solution, and that's not the intention. Evaluation and monitoring of staff. Staff, we have to be sure that is operating in a competent way, so that we can know if they need to be trained or retrained. So how can we do this evaluation and monitoring? One is to participate in proficiency tests. So for instance, when we are in we have from ISTA this programmed proficiency tests, as we saw in the beginning, in the welcome part of this day. As we are accredited, we have to go through some checkings. And if not, we have to make these proficiency tests and compare with different labs. Another possibility to have data to evaluate staff is to make intra-labs or blind samples evaluation. We can use those samples to compare with the analysts, the same sample that is studied by the same analysts. In the case of blind samples, they can come from a proficiency testing, or that some person responsible in the lab prepares these blind samples that the analysts don't know what they contain. Another thing that can be done is to register and evaluate specific mistakes, analysis mistakes or sampling mistakes, things that happened during the process, a review of all the different steps that we follow. It's important to register all that, to keep a record. Nothing should be lost. Everything has to be registered or recorded and controlled. So the lab has to record all the activities, not only for it to be an input for audits, but also that the lab can use that information for some special actions. For instance, in an evaluation of staff evaluations, for instance, a staff that underestimates something from ISTA. And as a last point, I would like to set as a critical thing the evaluation of trends. How do we do that? We have to have a criteria to do it. We have to try to register using control charts so that we can detect trends and do it fast, react fast, so that if there is an equipment that is deviating, or if it is not so easy unless you can put this information in a chart and analyze it. And this let us do it in real time and to see what happens with some things, and then make decisions as to train the staff or to, as a conclusion, we say that to assure the validity of the trials, nothing is lost, everything is recorded, activities are properly planned and controlled. Thank you very much.
Thank you for your presentation. Maybe in the past, many companies weren't sure about quality assurance, but now everyone knows that it's really important. Thank you for the information. And we have a question on the chat. Natalie asks about the tetrazolium solution. How long should the prepared solution be stored? The prepared solution should be stored for a year in a refrigerator. And the same goes for diluted solutions from the mother solution. Great. And for a technique that there's a technique that hasn't been accredited by ISTA. How are the results reported? How long should the records, internal reports, etc., be kept? That's very important, and I didn't mention this. How long should we preserve this information? ISTA states that it should be at least 6 years, and that is a reasonable term, so that we can access older information on the laboratory's work. If there are electronic records, in that case, it's not necessary to delete files, because the more information we have, the better. I think that focuses on labs that still have paper records, and actually we cannot store 10 years worth of paper in the lab facilities. If the technique is not accredited by ISTA, I'm sure they mean an international certificate. How is the report prepared? That is done in the other determinations section. We state the method used and the conditions as well. And we state that, I don't know, this is not included in the Easter rules. Great. We have some more time, so let's make the most of these questions. Is there just one, if I have just one analyst in the lab, how do I run an intra-laboratory test? If we have one analyst and one technical manager, then there are just two people, and the intra-laboratory work can be done with these two people. There are many laboratories that have just one analyst, and that analyst is a person responsible as well. And we wouldn't be able to call this intra-laboratory because we have no one to compare our work to. But the lab can still evaluate the performance. In this case, they would need to find a way. They could send a sample to INASE, for instance, or to another laboratory to compare the results. One final question. As analysts shouldn't deal with other activities, and as report writing takes a long time, who do you think is the ideal person to do this, to prepare reports? Well, we believe it's essential for the people in charge of the activity to write the relevant reports. We know that there are difficult times at a lab because of seasonality reasons. But this is very important for planning purposes. We need to consider these periods with less activity so that the professionals can actually write the reports. And it's actually the analysts themselves who should write these reports. Of course, someone might be in charge of reviewing or approving the document, but it's always essential for the person in charge of the test to prepare the report, to have a report that is as detailed as possible and that truly and accurately describes the work at the lab. Thank you. Now we have the second talk in this section. We would like to invite Maylen Arleo to the floor. Maylen has a BA in biochemistry and an MA in biotechnology, both degrees awarded by the University of Uruguay. She is a consultant at Escafe Asociados company. Thank you, Maylen, for being here today. You have the floor. Thank you. Good afternoon, everyone. Thank you, INASE, for the invitation to participate in this event. I am Maylen Arleo. I belong to Escafe and Asociados. We construct quality assessment systems. We basically work advising and auditing labs. This is a presentation called entitled Tips to Improve Lab Activities. First, I would like to show you a few questions that show us some of the problems that we can have at the lab to provide you some tips so that these problems do not occur as often. Maybe you are familiarized with some of the questions. For instance, I don't remember how to do something. Does it take you a long time to record what you've done? Do you run out of material? Does equipment fail all the time? Do you need to repeat an analysis to release a result? Our motto is to work more efficiently, not harder. We would like to give you 8 tips that can help you manage your lab more efficiently. First of all, you need to think of the laboratory as a process. What's a process? It's a sequence of interrelated activities in order to reach a common aim. This process entails the analysis request. Then the lab takes different steps, pre-analytical steps, analysis, and post-analysis. And there is administrative work to be done. This is a key process that has the support of other processes that we know as supporting processes. For instance, human resources, purchasing, clients, administration, and they help improve the efficiency of the laboratory processes. What does it mean to consider the laboratory process? You need to define the key stages for the laboratory, and you need to assign different responsibilities within that process. What does it mean to be responsible for a process? It's not the person in charge of the whole thing, but rather they need to have a holistic perspective so that the process works efficiently. And many times this involves delegating roles. When we can define the responsibilities, the key responsibilities within a lab, we can improve different responsibility allocation, we can delegate important tasks, we improve the process efficiency, and we reduce costs. Second tip, planning activities. What can be planned in a laboratory? Everything. First of all, tests. The lab needs to know the number of samples that enter the lab in a week, in a month, or in a given season. Because we need to allocate human resources and equipment as well, tools and inputs in order to work at a specific time. Regarding staff, we can also plan training sessions. We then prepare a training plan where we detect which courses or tasks we would like to plan and to help the staff work more efficiently. We also need to plan calibration, equipment calibration and verification. Therefore, we need to have this verification and calibration plan in order to manage resources wisely throughout the year and to have our equipment already calibrated and verified. We can also plan inventory. For instance, it's very important to have the necessary inputs, and this can be done weekly or every 15 days, taking inventory, so that we have the necessary inputs for our daily work. Another important element is planning document review. As you know, documents need to be reviewed because we need to work with current documents or objects. Therefore, although it's very important to have a document review, a document revision stage in order to keep the documents updated. Also, proficiency tests or interlaboratory tests, and also internal and external auditing processes. Another tip that is very useful, I believe it's one of the most useful ones, to promote the development and capacity building of staff, from people in charge of cleaning to the technical staff. All the staff should be trained, motivated, and informed about what they have to do. We could plan different training plans, and operational procedures should be very clear, and they should reflect the laboratory's know-how. We could have internal debate workshops and also proficiency tests. Regarding motivation, the staff should feel part of the laboratory to work efficiently. And we could hold technical meetings, for instance, to help the staff detect opportunities to improve. It's also important to have new projects. When we have our daily routine, it's very difficult to think about new projects. but there are always new projects and improvements, and the staff can be more motivated to embark themselves on new challenges. Also, the staff should be assigned new responsibilities so that they can work in a happy environment. And finally, they need to be included in those improvement opportunities. You need to discuss with the staff the different improvements that can take place to improve the work at the lab. Finally, one of the main points, which is not very efficient at different institutions, is communication. Communication needs to be fluent and continuous among the staff or with the top authorities or with the people responsible for the process. There should be coordination meetings in order to work with responsibilities. And now at the COVID era, we have different channels, Zoom, WhatsApp, groups, email, and all of them enable us to have effective communication. And we need to be very efficient at communicating changes because staff need to know about the changes that occur at the lab. 4, document elements logically. What do we mean by this? We need to just prepare the necessary information. If we follow quality standards, they say that we need to document every procedure at the lab, be them technical or management related. But this report writing needs to focus on what we're going to use. It's useless to have hundreds of thousands of records if we're not going to read them or follow up on them. So we need to identify the processes that are useful in the laboratory, and we need to document these processes. We need to avoid duplicating information in procedures. Many times we create a procedure, you include information, and then 3 more people enter the same information. So if we change this information or activity, we need to check 3 procedures instead of 1. And this entails a lot more work. So it's important to think about the procedures and to include the information in just 1 procedure. Also, avoid the use of unnecessary records. An activity can have 1 or 2 records or 10 records. It depends on how the recording system has been set up. We need to think about which type of information we need to collect and record the information and the communication based on that. Otherwise, it turns too hard to do. Also, regarding equipment verification and calibration, this can be recorded in just 1 registry because they share the same information. So instead of having 2 registries, we can have just 1. Tip number 5, analyzing trends, as Jessica said before. This means that we need to see how processes are working, how the equipment is working, what is happening with the staff, how the lab is working. And this can be done from technical records. We have technical records to analyze these trends. We can use control charts or graphs in order to easily see the trends, and also proficiency tests. These tests allow us to see comprehensively how the lab is working, how the methodology and the staff are working as well when using this equipment. Number 6, and this is very important, we need to record nonconformities. What is a nonconformity? Is not compliant with a requirement as established by the client or a regulation or the laboratory. So it's important to record those nonconformities. And how can we detect this nonconformity? For instance, through different activities, for instance, clients' complaints. For quality assurance, we can use controls, or for instance, regarding calibrations, the materials to be consumed, staff supervision, verification of test reports, management revisions, and internal or external auditing processes. All this allows us to record a nonconformity. What happens when we detect a nonconformity? First of all, we identify and record it. Once we have recorded it, we need to define responsibilities. What do we mean by this? It's not finding the person responsible for the nonconformity. It entails deciding who is responsible for the handling this nonconformity. We need to analyze the cause, why it occurred, in order to implement corrective action so that the nonconformity doesn't happen again. We also need to design follow-up actions regarding these corrective measures. These are 3 tools because the nonconformity handling is not easy. It's very difficult to find the root cause of the problem. So the causes are analyzed, and we have 3 tools to do this. First of all, brainstorming. In this case, the nonconformity is presented to the staff, and people brainstorm on what the most probable cause is. And after brainstorming, there is no censorship, and the most probable cause is focused on. And from that cause, then corrective action is taken. Then we have the 5 why tool. Why did this happen? For instance, I have a result that doesn't really match within the laboratory. Why? Because the expert didn't know the procedure. Why did they not know the procedure? Because the person in charge needed to train them, but they resigned and there was no training and there was no one else to do this. And why was there no one else to do this? Because this hadn't been planned for. No one noticed that this other person could resign. So this was a technical nonconformity, but it ends up being a management and planning nonconformity. Therefore, we have another tool, the Ishikawa chart. It's similar to a brainstorming session. At the head, we have the nonconformities, and throughout in the fish bones, we can see the causes: methodology, equipment, staff, environment. And that is placed on the fish bones, and we analyze which the most probable cause is. And after this is done, then the most probable cause is analyzed. What happens then with nonconformities? They are recorded, but sometimes they are not recorded correctly. The 6 main problems. First of all, they're not recorded. Number 2, nonconformities are someone else's responsibilities. I'm not going to record the nonconformity. 3, the root cause has not been properly identified. We choose a cause that is not the real one, so the nonconformity keeps taking place. Recording of absurd nonconformities. For instance, if I conduct a test and there is a problem behind the test, that's an accident or incident. It's not a nonconformity. Number 5, not defining responsibilities, which is another cause. And the last one, nonconformities are the responsibility of the management department. This always happens. People say this all the time. But nonconformities are everyone's responsibilities. We need to remember that nonconformities in the new rules are based on risk analysis. And this entails knowing the events that can affect the laboratory and define them and define the action plans previously. So for each event that can have a negative impact, I need to have a plan B. For instance, identify volumes of work, if there is a blackout, lack of staff, lack of inputs, equipment doesn't work, mistakes in reports, as Jessica was saying earlier, if there is a fire, etc. These are all risks that can affect the laboratory. So we should be able to have a B plan before actually this takes place.
Finally, we have to verify that we meet all the requirements. How do we verify that? Through internal or external audits. Through this, after this audits, we will evaluate the effectiveness of the management system. And then if we see if what we say we do, we are doing it and we do it right. We evaluate the conformity with the specified requirements, and very important with all these external and internal audits to identify opportunities for improvement, opportunities that lead us to grow. So finally, we want to leave you with this sentence for this event. Quality is to create a culture focused in a permanent improvement that allows us to add value to our organization. Thank you very much. We thank you, Mylin. Same as the presentation, the former presentation. It's great to have three presentations on this topic in an event like the one we are having today. Fortunately, we are giving it the place it's needed, and there are more and more companies that are joining this proposal. We have some questions from the audience. Melina is asking, how often are you doing the interlabs? That's defined by the lab. It depends on the standards or rules, quality rules that we are following, the competence requirement for calibration and competence. So they suggest that we do it every second year, but it depends on the lab. Another question is, when you handle a non-conformity, do you always need to take corrective measures? This is a nice question. There are two schools, the ones that say yes and the ones that say no. I will tell you what you find in the regulations. When you face a non-conformity, you have to justify it and take actions to correct the non-conformity. Those actions are called corrections. I am making an analysis and I realize that instead of using water, I was using alcohol. I realize that, and then I will correct this. And so this was a non-conformity that I noticed, I handled, and I solved. So I register this. If this non-conformity can happen again, or would it raise some doubts on how the lab is doing the tests? Well, if so, then I have to analyze the cause and take a corrective measure that will remove the root cause to make this mistake. So my personal opinion is that not always we have to take a corrective measure, but we must record the non-conformity, and if it's necessary, then we take the corrective measure. So thank you very much. One last question. Is it compulsory to have internal audits? Well, it depends. If we follow the standards, we are accredited and we are certified, yes, it's compulsory because the rules are requiring that. It doesn't say how often, but we have to make them. And if we don't follow a standard, we are not accredited, we don't have to. But anyway, it is a moment that let us review our management, to go deep on the management, on the functioning of the lab, and see improvement opportunities. That's a great part of audits. So it's not compulsory for the ones that are not authorized, but it's a good practice. Thank you very much. And as we ask Mariana to get ready for her presentation. And here we have in the chat a question about Uruguay, if it's implementing or deploying the the ISAIC is 1725. Oh, sorry, I missed the number. The INASE lab is accredited by the ISTA rule based on ISO or ISO. We don't have that accreditation because it was not requested by a customer, but we have all the information up to date. And if any customer would ask us to do it for any special reason, if it's for some business that they need it, we should we would be able to do it as soon as possible. We work to comply with everything that is specified there. So now we would like to welcome Mariana Pintos. Mariana is a bachelor, has a bachelor degree in technology and industrial techniques. She works in a calibration lab, LPGC. Welcome, Mariana. Thank you very much. Thank you very much for the invitation. As Vanessa was saying, we are a calibration lab. We are accredited by the Uruguayan agency based on this 17625 that came in the former question. So what we are going to see in this presentation is why and what for is calibration. Most of the people, when they are asked about calibration, we say that it is to comply with, to meet a requirement. It could be a legal requirement, regulation, or because the audit is demanding that, or some equipment, or everything calibrated. But in fact, what we should care about calibration is that we are sure that we are measuring the correctly. So let's see what is calibration, definition of calibration. For all the definitions we are using for this presentation, we will be based on the metrology definition. So calibration is an operation that under specified conditions is in a first step establishes a relation between the quantity values with measurement and uncertainties provided by measurement standards and corresponding indications with associated measurements, uncertainties, and in a second step, uses this information to establish a relation for obtaining a measurement result from an indication. If we want to understand this definition a little better, what we do, we compare the values with the uncertainties associated to the pattern and what the instrument or the tool is showing. So in a second step, we relate this result with the in order to find an indication. So this continues. A calibration can be expressed by a statement, a calibration function, a calibration diagram, a chart, or a table. We are used to see a chart with the values that are found, the pattern, and the uncertainty that is associated to that error. Calibration exists when there is a report pointing out the error and the associated expanded uncertainty. The 1725 regulation includes other requirements for a report. It puts in chapter 7 a series of points that must be included in the report. We are going to see some of these points. It's not very visible, but it has to have a title: calibration report, calibration certificate, and a number that identifies it. It has to be identified, the lab has to be identified also, the one carrying out the calibration, contact data, also who is requesting this calibration, contact address for the one requiring it, and we have to include the identification of the instrument, the brand, the code, the series Many instruments don't include this information, so many times we recommend the codification of the equipment so that you have a history of the equipment through the certificates with the same codes. So you can follow the history of the equipment. The calibration date has to be clear. The different dates for the issuing of the reports, the conditions under which the trial has been carried out, the method, traceability, metrological traceability. So it has to be included what was the pattern that was followed, the metrological certainties, and if it's necessary to adjust the instrument, you have to show the previous values and then the values after adjusting it and the things associated to the result. So there are more points, but this would be the most important ones. As I was referring, one of the things that it requires is traceability, metrological traceability. What do we understand for metrologic traceability? The definition is that it's a property of a measurement result of which the result can be related with a reference through an non-interrupted chain and documented of calibrations, each of which contributes to the measurement uncertainty. In this definition, the reference can be the definition of a measurement unit through the practical, some practice, or a procedure of a measure that has a measurement unit that when it's some magnitude or a pattern. This is all the chain we have to follow to reach the pattern that is the reference. So the important thing of this definition is that the method used to calibrate is very important. It's not the same if I calibrate a weight using the method than if I just grab the weight and put it on the scale. So that's a big difference. In the case of calibrations of these instruments, we use it we use a scale so that you can understand traceability and hierarchies. The scale we use is calibrated with a weight calibrated by our lab. At the same time, this weight is calibrated with the weight of the National Metrology Lab, the LATU in Uruguay. And that one of LATU is calibrated by an international metrology institute, and that weight is traceable with a pattern weight. So there you have all the metrological traceability chain. You can see the pyramid on the right-hand side of the slide, and that's about hierarchy. When we go down on the pyramid, we increase uncertainty of the measurement. Why? Because the equipment I'm calibrating below will depend on the uncertainty of the one on top. So it will be bigger because there are other reasons that affect the uncertainty. Now that we included the idea of uncertainty, let's see the definition. Uncertainty is a non-negative parameters that characterize the dispersion of the values of something that is being measured, taking as a reference the information that is used. So what are the factors that affect uncertainty? The pattern for calibration, the environmental conditions, the method that is used for calibration, how the expertise of the calibrator, the instrument. So there are several factors that contribute to uncertainty. So we have to assess all these factors to give a proper result. This is a lot of statistics. There is a lot of information about this, but this is not something we should deepen now. So as a summary, what do we get from calibration? What is important? We get a report that is telling us about the error of the instrument we are using. So tell us how we are measuring an uncertainty associated to the error. So it will tell us what's the margin where our value can fall, and traceability to national and international patterns. So when I ask for a calibration, the lab is issuing a certificate, and it says it was calibrated with this scale and this certificate. How can I know about traceability if there is a metrological traceability? That's why we have accreditations. When in Uruguay, we have the Uruguayan Accreditation Agency, and this assures that we have the technical competence to do the calibrations that are according to the scope. So when this agency is giving the accreditation, it was following this 17025 standard that assures the customer that all the issues are handled and they are met. So let's see some examples on how to understand some results and what's the purpose of calibration. We have the calibration of the thermometer of a germinator. The incubation temperature is 30 and our tolerance is ±2 centigrade degrees. In one case, we are going to see the result when we are setting the germinator to 30. We have a reading of 29.6 in comparison to the pattern. So the uncertainty informed is 0.4. So my value can change from 29.2 and 30. Let's see it in a chart. This is a value we got, and the temperature area where it can we can vary, so there can be an uncertainty. So we can see that we are inside the tolerance, so we can assure that we are meeting the established criteria. Another case would be that reading the pattern, then we get 28.2 in the uncertainty. It could be between 27.8 and 28.6. So if you check the graph, there is an area that is outside the control. So we cannot assure that we meet the criteria or the requirement because it can drop out. The third cause that is more extreme, that is directly, is 27.5, is outside the tolerance plus uncertainty. All the probability is outside the requirements. So the first case is not a problem, and we can also look for solutions. The first one is to fix the equipment to correct that error. It can be adjusted and it can be corrected. The other one that is easier, we can change, for instance, in number 3, if I know that in 30 it shows 27.5, if I put it on 32.5, then it would be 30. For that purpose is that calibrations are useful, so we know what we are measuring, and also to correct and comply or meet the requirements. Another example could be a scale to pack a product. And here you are packing 25 kilo bags. When we calibrate and we put a 25 kilo weight, we read 24.5. So when we are loading the bag, we are loading 25.5. We are giving away half a kilo of the product. If we put the weight, the standard weight, and it is 25, when we go to 25, we are missing half a kilo. So this could be that we get a complaint, a non-conformity, or the customer is not satisfied. So for all these reasons, it's important to know what we are measuring. So as a summary, why do we calibrate? To assure that our trials, to have an efficient performance of our plant. Safety. We didn't speak about safety, but imagine something that is not properly regulated in a, and the valve. So this is the requirements can be, if we are not meeting them, they can be dangerous in something that requires high temperatures or fire, so or heat. Why do we recalibrate? Because of the use, because of the environmental conditions. So we will see an example. This is the weight. The green line is it's a conventional thing. And the red is an uncertain. No, the red is the limits that are allowed, and the purple is uncertainty. So there is a moment when it's important that the weight is dropping. So the calibration, so we can see a trend that the tolerance is going away. We are coming out of the tolerance.
Maybe we can use the equipment for something else, or we correct the measurement and we change the ranges. And this is what calibration and recalibration is useful for. In this case, we can see what happened. The tolerance is not respected anymore. But as we used this with a mass correction, it didn't affect the measurement. It's as if we had changed the error range. This is called the instrumental drift over time. What is the definition of instrumental drift? Continuous or incremental change over time in indication due to changes in metrological properties of a measuring instrument, VIM 3rd edition. Drift can be caused by frequency of use, training of the staff using the equipment, environmental conditions, and instrument quality. How do we set a calibration frequency? We need to take this into consideration, this affecting the drift, frequency of use, environmental conditions, use conditions, and equipment quality. These are very important factors. How can I then set this frequency? Sometimes there is a requirement. Someone tells us that equipment needs to be recalibrated every year, and we do so, and then we can evaluate how the equipment evolves over time. Sometimes you can have mid-term verifications through calibrations when we don't. I'm not familiarized with the equipment or with the brand, and so we can see how the equipment is performing. After the study, we can do two things. If the equipment tends to drift from the right measurement, then we need to calibrate the equipment more often. But if the equipment is stable and there is no regulation requiring that I conduct a recalibration, I can extend the calibration term. What really matters is that before stop using an equipment, a piece of equipment, we need to decide what to do with the calibration, because that when I calibrate a piece of equipment that I will stop using can tell me how accurate this instrument has been over time. And if this happens, then I need to study all the measurements I took with this piece of equipment if it's out of range. So we need to consciously determine the calibration frequencies. There are other concepts that are easily confused with calibration: verification and adjustment. Verification is a provision of objective evidence that a given item fulfills specified requirements. For instance, I verify the scales. I put a weight on the scales and I get 20 grams. Okay. There is tolerance for verification. If it's out of range, then I cannot work, and I need to decide if I need to make an internal adjustment, and the result is good, or maybe I need to recalibrate, repair, whatever. And then there is a concept of adjustment, set of operations carried out on a measuring system so that it provides prescribed indications corresponding to given values of a quantity to be measured. This entails modifying the error, trying to bring down to zero this error. This can be done with some equipment, but not with other types of equipment. Sometimes the adjustment can be made or not. So these are several concepts. Maybe I was a bit too quick, but hopefully I was clear enough. If you have any kind of questions, please let me know. Thank you so much, Mariana. As you were saying earlier today, and from authorized laboratories, we always try to reinforce the importance of calibration. It shouldn't just be that, I don't know, I need to calibrate the equipment because it is an INASE requirement. Actually, calibration is essential, and hopefully many of the labs we visit have heard this presentation and they can make the most of calibration in general, and not just because it's a requirement. Yes, sometimes they just don't look, and the equipment does not comply with the measurement requirements. Yes, of course. So they ask you from Costa Rica, what do you think about mid-calibration verifications? They are very important because, as we were saying before, sometimes you're not very familiarized with the equipment, or the opposite. You know it, you've known it for a long time, and you know it's somewhat old and it's not working as well as it did before. So what I do is I bring forward the calibration, and sometimes an adjustment can be made, and it allows professionals to continue working with a piece of equipment. So the idea is not to work blindly. Great. Another question, can the calibration lab report if the equipment is suitable for the relevant use? Yes. The lab, there is this new regulation 70,025 that states that conformity can be reported because of a regulatory requirement or because a client requests this. The client needs to tell us which the tolerance is, because maybe they'll tell us, but can I use it? It depends. What do you use it for? What's the tolerance level in this process? We can add in the certificate something like it fulfills the needs of the client, but to do that we need to know the tolerance. They ask us about pH meters. Is adjustment made with a are adjustments made with a buffer? Yes, what a pH meter calls calibration is an adjustment and not a calibration. Finally, Is it necessary to calibrate all the pieces of equipment in a lab? No, it depends on the use. For instance, you might have thermal equipment, for instance. Maybe you have one that is calibrated and they are at the same temperature, and I can see that they are coherent with each other, and you don't need to calibrate all the thermal hygrometers. This goes against my own interests, but oh well. Thank you so very much. Hopefully this has been a very fruitful presentation, and hopefully people have enjoyed it. Thank you. Now we will have a panel with our panelists. Here we have some questions that we will pose to them so that you can maybe change your mind or have a new opinion. First of all, should laboratories adapt to the expiration dates of the calibration expiration dates as determined by external companies? Well, as Mariana said in her presentation, not necessarily, because the laboratory must set these frequencies depending on the equipment use, how old the equipment is, because of the effects of instrumental drift. Mariana, sorry, Mailen first Mailen. Well, actually, Mariana is the expert. As for the rules, the laboratory should not do this because it's not a requirement. But they can do this according to the provider's expertise. So if you are a bit lost and you don't know how to determine that date, you can follow the provider recommendations as such. And it depends on what Jessica and Mariana were saying in the presentation. It depends on the instrumental drift, on the use of the equipment as well. And now the expert. As I said in the presentation, the lab does not know how the equipment is used and what the requirements of the client are, as said by other parties. So the lab cannot determine the frequency. We would love to have to calibrate pieces of equipment more often, but it's actually the user that needs to determine these frequencies. They need to be part of a program, and the instrumental draft and other factors need to be studied because they affect measurement quality. Thank you. Is it necessary or recommendable to audit calibration providers? And first now, Mariana. I think it's not necessary. It can be done. As, for instance, when a laboratory is audited, we already have a third party auditing, and they are technically competent in the area. If there is, I don't know, there's these clients that evaluates how we calibrate scales, they lack the necessary expertise. They might have it, but probably they won't have the technical competence to understand uncertainty in studies and other factors, and they will not be able to evaluate our work. They might be able to evaluate if our work adheres to the corresponding ISO standard, but that is already evaluated by the accrediting institution, so it wouldn't be necessary. Thank you. Mailen. Yes, I agree with Mariana. Actually, and going back to the rules, we must evaluate the provider. We need to evaluate the provider. This doesn't mean that we should conduct an audit. We have different types of evaluations. It is necessary to evaluate the providers, but not necessarily through an auditing process. Of course, it's advisable to conduct these audits because they tell us a lot about the management system and about how these labs work, and especially calibration services. So they can, it's good to audit a provider. It's a good idea, but it's not mandatory to audit the provider. I think I have nothing left to say. It's actually the combination of both opinions, because it's not necessary. It's a good practice, as is usually the case of audits. Many laboratories still follow this practice because of external requirements. And maybe in the seed area, it's not that necessary because we do not have a requirement. Of course, we need to conduct internal auditing and we need to evaluate providers, but not through audits. Great, thank you. Your replies have been very clear, and I think they help everyone who is listening to us. And of course, they have now your contact in case they need to ask you any questions. Thank you to the three of you. It was a pleasure to share this panel with you. Your presentations have been very clear in writing and here in person as well. Thank you very much on behalf of INASE for your time.
Well, now we are closing our activity. We would like to thank you all that followed us the whole day. We hope that you were enjoying this event. We apologize because there were questions that we were not able to answer, but we will send them to each of the speakers so that they can answer them. And we also will keep this network, this contacts network, as we announced in the beginning of our event, to organize an event next year with another, to handle other topics, or at least to deepen in these topics. For the closure, I would like to introduce you to Álvaro Núñez from INASE, the president of INASE. Good evening, good afternoon. I don't know where you are. So it finished, and it's a great challenge to prepare for next year. I would like to thank the most of 580 people participating from different countries. We had about 780 people that registered for this. I hope this was according to your expectations. For us, it went above our expectations. So we hope it was helping you. Our purpose was to share knowledge with you, share this activity with you, and also show Uruguay as a country that can do things of this level. As I say, Uruguay is an agro-industrial exporting country, and we have the focus on quality, to have a legal framework that provides warranties, and this generates trust, and that's what we want to export to the world, trust. Of course, our role from INASE is to assure quality, and we give a lot of importance to all this, and that's why all this work that was very focused on quality. We would like to especially thank all the speakers of this day. We would like to highlight the technical level that of all the presentations from both the public and private sector. We would like to thank Ignacio Aranciaga, Victoria Gualtierra, Teresita Ferraz, Nicolás Grison, Silvana González, Ana Laura Pereira, Alejandra Firenzi, Rosina Fossati, Maylena Arleo, and Mariana Pintos. And finally, to thank the INASE team, to the lecturers, to all the ones that are part of INASE, Melissa Cuadro, Vanessa Sosa, Mariana Menoni. Vanessa Sosa, it must be exhausted because she was working the whole day here interacting with you, and Danielle, the executive director, and our colleague, and all the ones that cooperated from their own positions in with this event. That was a big success. Behind all this that you were seeing, it was the whole institute and the lab. And finally, the ones who were paying attention to the INASE website, you were able to share some sentences or some ideas, and I would highlight one that I liked especially: what's not thought is not measurable. What you don't measure, you cannot improve, and what is not improved is always degraded. It was said by William Thompson. So thank you very much. It was a great pleasure to share this activity with all of you. Same from here. Thank you very much.
La Alemán, una empresa de biotecnología aplicada.
El Laboratorio Tecnológico del Uruguay, LATU, es referente nacional e internacional en servicios de análisis de laboratorio, certificación, control, aseguramiento de la calidad y en la promoción del ecosistema emprendedor uruguayo. El LATU constituye un respaldo para el desarrollo de las distintas cadenas productivas industriales y agroindustriales del país, como la láctea, forestal, cereales, oleaginosos, entre otras, y la certificación de la calidad a nivel nacional y ante el mundo. En su rol de Instituto Metrológico Nacional, asegura que las mediciones que se realizan en el país sean exactas, confiables y comparables tanto a nivel nacional como internacional. También realiza el control de todos los instrumentos reglamentados y de los productos envasados premedidos que se comercializan en el país.
Una vez más, acá estamos, acercándote a lo que va a suceder en tu campo cada día, cada campaña y cada amanecer. Porque acompañarte, ofreciéndote las herramientas y el servicio que necesitas para crecer, nos permite estar más cerca tuyo, siempre. Estamos en cada etapa, sumando soluciones y experiencia. Porque siempre que estamos cerca, crecemos juntos. Lidera Semillas. Estamos cerca. Estamos siempre.
Prolesa es una empresa privada que pertenece al grupo Conaprole, la cooperativa láctea insignia del Uruguay. Hoy es la mayor red comercial del país en ese rubro, ofreciendo la más amplia variedad de insumos y servicios necesarios para la producción lechera. Actualmente, la empresa desarrolla su esquema comercial organizada en 8 unidades de negocios. Estas unidades permiten suministrar a los productores lecheros la más amplia variedad de insumos y servicios necesarios para que ellos solo se dediquen a su trabajo, la producción de leche.
Una persona sembró maíz, trigo, arroz, y así la humanidad pudo crear todo lo demás. Pero ¿quién hubiera dicho lo grande que iba a llegar a ser la civilización? La agricultura tiene que cambiar, y lo está logrando. Somos Corteva AgriScience y estamos para apoyar a las personas que nos alimentan. Con semillas más fuertes, protección de cultivos precisa y avances en agricultura digital, estamos acercando a la próxima generación de la agricultura a la próxima generación de productores. Corteva AgriScience. Sigamos creciendo.
Estos granos son del campo. Estos granos provienen de un campo diferente. ¿Puede adivinar qué puñado de granos es mejor o peor? ¿Cuál es el adecuado para panificación? ¿O cuál es bueno para ración animal? Cuando la tormenta se acerca, ¿cuál deberíamos cosechar primero? ¿Cuál de ellos nos proporcionará el mejor precio? ¿Pueden ser mezclados? ¿O puede la mezcla perjudicar el rendimiento? No, no puede adivinar. La calidad del grano no es visible. Para conocer la calidad del grano, el agricultor debe tomar una muestra y enviarla al laboratorio, y después esperar y esperar. Hasta ahora. GrainSense le indica la calidad al instante y en el campo. Beneficia a los agricultores, a los compradores y a todo el mundo. GrainSense, un laboratorio en las manos de cada agricultor.